Let's take a look at problem number 2. Now that we have the basics, we're going to cover this one a lot faster. A survey of 1,103 randomly selected Americans showed that 281 thought the sun goes around the earth. With a 97% level of confidence, construct a confidence interval about the population proportion of Americans who think that the sun goes around the earth. Being that this problem is a proportion problem, just like the last one, the correct sampling distribution is the standard normal, or the Z distribution. Our level of confidence is 97%, or 0.97, which implies that our alpha, or error area, is 0.03. Alpha over 2 is 0.015. When we look that up on the spreadsheet, we will get a Z sub alpha over 2 of 2.17. On the Gaussian curve with a mean of 0 and a standard deviation of 1, this is what it looks like. This area right here represents 1.5%, or 0.015, and this area right here is 0.015 on the right side. Our parameters are as follows. N, or the total number of people in the survey, is 1,103. X, or the number of people that responded in a particular way, is equal to 281, which means that P hat is 281 over 1,103, approximately 0.2548. Q is always 1 minus P, so Q hat is 1 minus P hat, and that's approximately equal to 0.7452. Here is the formula for E with the parameters plugged in. This is what my confidence interval works out to be after I subtract my 0.0285, or my E, from P hat, which is shown over here, and when I add 0.0285 to my P hat, which is shown over here. When I do the simple arithmetic on that, I get a confidence interval of 0.2263 is less than the population proportion, which is less than 0.2832. In other words, because we use the 97% level of confidence, I can be 97% confident that if I surveyed the entire population under consideration, that somewhere between 0.2263, or 22.63%, and 28.32% of Americans in this case would think that the sun goes around the earth. Let's pop this on a spreadsheet. We'll go right to spreadsheet mode. You'll see how fast this goes. Here we are in spreadsheet mode. My X from problem 2 was 281. That's the number of people that responded in a particular way. My N, or the total number of people in the survey, was 1103. Now, I just realized that I made a mistake when I originally set up the spreadsheet, so let's correct it now. It's kind of a simple mistake. I typed in a literal, meaning I typed in equals 93 over 126, which was from the previous problem. But that's an easy fix. All I have to do is change that to equals, and then I'm going to click on the actual cell that contains my X value, which is what I didn't do last time. divided by the cell that contains my n value. Make sure you make that correction, or it's always going to show up with the same p-hat value. And there we go. And now these numbers match up to what I had on the actual problem and then the description of the solution to the problem. My level of confidence is 0.97. Alpha becomes 0.03. Alpha over 2 is half of 0.03, which is 0.015. My z sub alpha over 2, or the z value for the left tail, is negative 2.17. And the z value for the right tail is just the positive of that, so it's positive 2.17. When I put that in the formula for E, I end up with, again, the number that I showed you on the actual description page of the problem. I end up with 0.02847, or I might have put 0.0285. And when I subtract that number from my p-hat value, which is this number on the left, that's what I get. And on the right side, I get the 0.2832 number from adding E to p-hat. If I were to interpret this result, it would mean that we can be 97% confident that the population proportion of those that believe the sun circles around the earth is somewhere between 0.2262 and 0.2832. Or you could say it as a percent. We can be 97% confident that the percent of those that think that the sun circles the earth is somewhere between 22.63% and 28.32%. So you see, once we have these spreadsheets set up, this goes very quickly. And now we're done with problem number 2.